We all had one of these babies at some point. He was a cool kid at the play school, and you may have bet away your last euro on a race with these Slinkies. Well, you're never going to lose again. Surprisingly, there's actual science behind this big boy spring. Let's find a bit about it.
Richard James, a mechanical engineer, was working on trying to invent a spring that could keep sensitive ship equipment steady at sea in 1943. One day, he accidentally knocked some samples off his shelf. Then he discovered how gracefully they walked down instead of falling. Him and his wife decided to demonstrate the toy in Gimbel's department store in Philadelphia. They were so scared that no one would buy their toy that they gave $1 to one of their friends to buy one. A half an hour later, after the demonstration, they had sold over 400 Slinkies. The Slinky draws a lot of attention by its mesmerizing, elegant movements. Between 1945 and 2005, over 300 million Slinkies have been sold. The Slinky made it into the top 100 greatest toys of all time. Over many years, the Slinky has only been modified once, and that was to crimp the ends of it for safety. The spring of the Slinky can spread out and snap back just like an accordion. There is 3 different types of energy formed when using a Slinky: potential energy, kinetic energy, and momentum. For example, you can use potential energy by pushing a Slinky down the stairs.
The physical properties of a Slinky determine how quickly it moves under the influence of gravity. Although the way it moves looks quite simple, from a scientific point of view the motion is quite complex. As the Slinky moves down the steps, energy is transferred along its length in a longitudinal or compressional wave, which resembles a sound wave that travels through a substance by transferring a pulse of energy to the next molecule. So basically, the energy travels around and around and around the spring. How quickly a wave moves depends on these 4 things: the mass of the material the Slinky is made from, the length of the Slinky, the diameter of the coils, and the height of the step. This should be considered completely to understand why the Slinky moves the way it does.
Okay, so now for a final experiment. Let's put these 2 Slinkies side by side. One is made out of metal and is heavier, and its diameter is way smaller. The other one is plastic and shorter, but yet its diameter is even bigger. Let's see which one goes down the stairs first. Let's place our bets. Thank you all for watching and paying attention.
Our stairs experiment has shown us how 2 different Slinkies act. The metal Slinky, which has larger mass and tension, moved down the stairs smooth and quickly. Kinetic energy transferred from coil to coil in a longitudinal wave. The speed of the wave depends on tension and mass of the Slinky. Tighter the tension, the faster the Slinky.
I hope you learned something new, because we know that we sure did.